Hello and a warm welcome to my infrared YouTube channel. Today I want to show you some applications of heat to thermal infrared, long-wave infrared, as in electronics, in architecture, house maintenance and medicine. The outline is, first I'm going to show you some typical cameras and tell you roughly what they would cost. And then we will look at an application in electronics, and then architecture and house maintenance, and in the end the most difficult one is the medicine. So first, a couple of cameras, as you can buy it in the internet. Some can be combined with smartphones, so you don't have to buy an extra screen, but there are also the ones with extra screens, and they tend to be relatively cheap, the ones that you use for technical applications or house maintenance. Here is a camera that is mainly used for hunting, and this is a very expensive one for architecture, house maintenance. As often the chips may be similar between these and these. Maybe this one is a bit larger, but they are vanadium oxide chips anyway, and they're not very sensitive. Resolution gets better and better over the years, but probably this camera more or less tells you what to do, whereas in these you have to do the thinking on your own. Some have fast readout rates like 50 images per second, and the other ones are a bit slower, maybe 5 or 9 images per second, which is completely fine for static things. Something you have to know is that the emissivity parameter, which is something you can program into a camera like this, for example. Polished metal has around 0.1 emissivity. Flat paints tend to be around 0.9, and human skin or water is around 0.98. This has the advantage that if you choose maybe 0.95, you're well off for most surfaces, except metals. Now we have a short look at electronics, more specifically at computers and laptops. With thermal cameras you can see how they heat up, and this also up to a certain degree predicts how long the computer is gonna work, because if it's too hot it's gonna cook its own electronics. Here there are some examples, and your laptop that reaches some 44 degrees, which is not a problem at all. Here you also can see a small transformator in the background. This is something you have to keep into account. Also, each trafo costs some energy because it produces heat. An older laptop here heats up until 51 degrees, but as you can see here, the hottest spot is actually this dongle. That is an analog digital converter. And an even older laptop here also heats up most to the left side, so this is probably where the electronic parts are that produce most heat. For example, the image card of the computer. Actually, here you can see that some heat went away from this picture to this picture, which was the hands of the person who used the computer. This doesn't have anything to do with the heating up of the laptop itself. Now a second applications we will look at is architecture or house maintenance. You can go outside, preferably in a cold night, and take pictures of a house. And then a typical not very well insulated house will look like this. Often the windows lose most heat, as to be seen in the warm colors here in this color coding. But here you also see that under the roof quite a bit of heat is gonna escape, which is something that can be improved in a house. And another problem that can be looked at is humidity. It's a bit harder to detect, but often on flat roofs, for example, if you have lots of heat in a spot, it could be humidity that has to be looked at. Here there's the example of my own house, and some 4 years are between these pictures. So at first glance this one looks a lot worse than this one, although the difference is not as large as you may think, because here I included lots more sky, and the sky is very cold. So it's not really a fair comparison. And the other thing is you also have to look at outside and inside temperatures. If you heat your house up a lot, the losses will be also larger. And if it's very cold outside, the losses are also larger. But qualitatively speaking, if you look at the images, that's how you can tell where the hottest spot or the most energy is gonna leave the house. And here, for example, you can see in the middle of the wall there's the hottest space, whereas after outside insulation, the hottest space is actually the corner of the window, which is something you would expect. Here there are some examples that could or should be improved. Here on the roof extension you can see plus 10.5 degrees in a cold night, so lots of heat is just leaving by this spot, whereas the rest of the house is much colder, is around 1 degree, which is not too bad. So the details matter, because there you lose warmth, and probably also the air is drafting through here, I would assume. Here on the terrace door you can see a cold spot because we're looking from inside. So here is 8.4 degrees, which is quite a lot under the 19 degrees that you have in this room. So some temperature goes away here. It's not something that could be fixed easily, actually. And you also can tell something about the build quality of the house by looking at these heat images, because sometimes you see not only at the wall but inside. For example, here everywhere we have these lines on top of the windows, sometimes quite bright. Also here. So there's some heat loss there. And if you look more closely here, there are even the bricks you can see. So normally a brick wall would insulate quite well, but here there are some gaps in between. I have no idea why they did that, but probably they finished the wall first without the windows, and then only then put the windows inside, and then there was this gap and they more or less filled it, but it was hard to fill it exactly. That's why there are some gaps. Also here there are some gaps, and you have no possibility to find these gaps unless you take it apart or you take a heat camera. By the way, here there's this very bright thing which is the gutter. The gutter is made of metal, and here the temperature is probably not estimated in a right way because I assumed an epsilon of 0.95 and the metal should have an epsilon of 0.1. Now the last range of application is the most difficult one, which is medicine and diagnostics. If you look at the body from outside, you can also see the hottest spots. Quite typically, the hottest spot is the neck of a person. The head is also quite warm normally. So if you look at ears or eyes, you have almost the same core temperature as if you look at the neck, but the other parts of the body are normally quite a bit colder. And the heat follows the bloodstream, so where you have lots of fresh blood, you also have the warmest temperatures. Then you can look at asymmetries, and maybe you will see cold spots when, for example, muscles cramp and block the blood circulations. You will see colder spots. You can also see hotter spots. For example, if there's inflammation, lots of blood will go inside and it tends to be hot, which is actually something the body does on purpose to fight off bacteria or virus. You can also measure fever by just taking pictures. For example, where many people pass in an airport or something. And as you can see on this example, there are 3 persons where the camera gave out temperatures and none of them has fever. As for this kid, it's a critical case because the temperature around the eyes is 100.5 Fahrenheit, which is 38.1 Celsius, which would be fever for an adult person, but for a kid it's still okay to have 38.1 degrees, I think. And it can also be used for mammography to look for cancer, because a cancer, especially bad cancer, will make a lot of heat. And here you see the normal breast of this woman, and here in this breast you have heat coming out, so it should be looked at what is inside here. And there's another even more clear-cut example where there is something tubular going away from the armpit into the breast, and this is something that doctors certainly will want to look at. Maybe looking at breasts is simpler than looking at other parts of the body because there are no muscles and there's not much heat produced in a breast. So if heat comes out, it's easier to interpret what that could be. So thanks a lot for the attention.